name is Molly Williams, and I'll be teaching you today about Hardy-Weinberg law, and I'll be showing you a practice problem. In Hardy-Weinberg law, allelic and genotypic frequencies will arrive at and remain at equilibrium frequencies after one generation of random mating if all assumptions are met. The assumptions are as follows: infinite large population, random mating, no selection, no migration, no mutation. At equilibrium, the genotypic frequency are represented by Hardy-Weinberg equation, which is p squared plus 2pq plus q squared, where p is the frequency of the big B allele and q is the frequency of the little b allele. In a practice problem today, we have a population of penguins that live on an iceberg in Madagascar. We have a population of 500 total penguins. We will see 240 blue penguins, which are represented by big B, 205 pink penguins, which are represented by big B, little b, and 55 purple penguins, which are represented by little b. Now with this information, we're going to calculate the allelic frequency. The allelic frequency of big B is 0.685 and little b is 0.315. All allelic frequencies must add up to 1, and using the Hardy-Weinberg equilibrium, we're going to plug in the numbers for P and Q, and they're all going to equal 1 to find the genotypic frequencies. We will use our observed population, allelic, and genotypic frequencies to find the chi-square value, which is 1.2468. Since we have 1 degree of freedom, our critical value is 3.84 at a 5% significance level, and we fail to reject our null hypothesis that our population is in Hardy-Weinberg equilibrium because 3.84 is larger than 1.2468. A family of sharks have attacked our population of penguins. The pink and blue penguins were attacked the first because they were closest to the edge of the iceberg. This is an example of selection. The number of blue and pink penguins decrease and the number of purple penguins increase. To find out how selection affects the penguin population, you have to first find the fitness of each genotype. After completing the chart, we can find the initial allelic and genotypic frequencies to the ones found before and after selection. Looking at the frequencies of homozygous dominant and heterozygous genotype, the frequencies decrease after selection. The frequencies of the homozygous recessive increase. This selection is called directional selection and can be shown in the graph above. The fitness that was given affects genotypic frequencies. Fitness is the ability to successfully produce offspring. In Hardy-Weinberg equilibrium, each genotype has the same fitness. And if fitness of an organism changes, then the genotypic frequency will make the population not be incoherent to be Hardy-Weinberg equilibrium.